Alright guys, welcome back to Underground Science, and in this video we're going to be talking about purine synthesis. Specifically, we're going to be talking about drugs that are involved in purine synthesis, okay? Because there's a lot of drugs that inhibit certain enzymes in purine synthesis. Alright, so let's go and get started. First enzyme we need to focus on is glutamine phosphoribosylate aminotransferase, and remember that converted PRPP to 5-phosphoribosylamine. Okay, but there's something else that we need to talk about first, which is, or there's actually the drug that, let's mention the drug right now, is 6-mercaptopurine. Okay, 6-mercaptopurine. Something else that we should know is that azathioprine is actually the prodrug for 6-mercaptopurine, right, or prodrug to 6-mercaptopurine. What that means is azathioprine will get converted into 6-mercaptopurine, okay? And the cool thing about this, right, is that, let's rewrite it, 6-mercaptopurine. The cool thing about 6-mercaptopurine is that we have this enzyme called hypoxanthine guanine phosphoribosyltransferase, okay? This enzyme is important in the purine salvage pathway, which we will talk about in a future video, okay? But just a short, intro to this enzyme is that we have these two molecules, okay? One molecule we should know about is called hypoxanthine. Okay, and another molecular base we should know about is guanine. So hypoxanthine in the purine salvage pathway can actually get converted into IMP. Okay, and guanine can get converted into GMP. And guess who helps do this? Hypoxanthine guanine phosphoribosyltransferase. Okay, so this enzyme will help make these processes go forward. And notice what's in the enzyme's name is phosphoribosyl, right? So we can add a PRPP. We actually what happens is we need a PRPP in these reactions in order to make IMP, in order to make GMP. Okay, but the main thing is that this enzyme, hypoxanthine phosphoribosyltransferase, right, is really important when it comes to activating 6-mercaptopurine. By that, what I mean is 6-mercaptopurine, right? This is actually kind of a cool reaction. 6-mercaptopurine can get converted into 6-thioinosinic monophosphate. Okay, so what's this molecule called? 6-thioinosinic monophosphate. All right, and the reason why I'm mentioning this, right, is so again, let's just write it right here. So what stimulates this reaction? Who helps convert 6-mercaptopurine into 6-thioinosinic monophosphate? We got hypoxanthine guanine phosphoribosyltransferase. Okay? Now what happens is this 6-TIMP will go to our enzyme that we saw on the previous page, which was what? Glutamine phosphoribosyl aminotransferase, right? Aminotransferase, all right? Or also called what? PRPP aminotransferase. 6-TIMP will go and inhibit this enzyme. So what's the after effects of that? Let's go back. So this is the enzyme that 6-TIMP will inhibit. Okay, so remember, if we just quickly mention here, 6-mercaptopurine, with the help of hypoxanthine guanine phosphoribosyltransferase, will get converted into 6-thioinosinic monophosphate. 6-thioinosinic monophosphate will inhibit glutamine phosphoribosyl aminotransferase. Okay, if you inhibit this enzyme, look what this does. Glutamine phosphoribosyl aminotransferase helped convert PRPP into 5-phosphoribosylamine, right? And then 5-phosphoribosylamine got converted into inosine monophosphate. And then with inosine monophosphate is how we made what? We made AMP and GMP, right? And also deoxy-AMP and deoxy-GMP, which are important for purines, right? Without IMP, we can't really make purines. And so what that means is, when we're talking about the purine synthesis pathway, right? Because remember, short refreshers, that IMP is how we, from IMP is how we actually make AMP and, if we scroll over here, GMP, right? And deoxy-GMP. So without IMP, we can't make those in this pathway. So if you inhibit this enzyme, you can't really move forward, which means you cannot make IMP, right? If you can't make IMP, you can't make GMP and deoxy-GMP, or you can't make AMP and deoxy-AMP. So that's how 6-mercaptopurine and azathioprine, right, inhibit glutamine phosphoribosylmalate transferase. So that's how they participate in inhibiting purine synthesis, okay? So we have two drugs so far, 6-mercaptopurine and azathioprine. Another thing, since we're on this enzyme, right, let's do this in a different color. IMP, right, which we make in the future, right, after 5-phosphoribosylamine, that gets converted to IMP, and then GMP and AMP, right? All of these molecules can actually come back and inhibit this enzyme also. Okay, so that's good to know too. So we have 6-mercaptopurine, azathioprine, and these molecules that inhibits glutamine phosphoribosylamide transferase. Next, let's talk about methotrexate, okay? So so first, let's just note this, okay? So see 5-phosphoribosylamine right here, that gets converted to IMP, right, inosine monophosphate. What's one of the things we need, right? Look at here, formal tetrahydrofolate is one of the 6 things that we need in order to convert 5-phosphoribosylamine to IMP. Well, look at this, tetrahydrofolate. Let's focus on the tetrahydrofolate part. If you need formal tetrahydrofolate to convert to IMP, and we know from IMP we make GMP and AMP, then that means tetrahydrofolate must be an important molecule in order for purine synthesis to even occur, right? So if we go ahead on a different page, so we focus on tetrahydrofolate, right? Because we need formal tetrahydrofolate. Well, how do we even get tetrahydrofolate? From dihydrofolate, right? So dihydrofolate is how we get tetrahydrofolate. But how does this reaction even happen? We need dihydrofolate reductase, okay, which we talked about in the pyrimidine synthesis pathway. Okay, we need dihydrofolate reductase in order for dihydrofolate to get converted into tetrahydrofolate, right? But what if dihydrofolate reductase wasn't working? Would we be able to make tetrahydrofolate? No, right? And if you can't make tetrahydrofolate, we can't convert 5-phosphoribosylamine into IMP like we saw on the last slide. And if you can't make IMP, you can't make AMP and GMP, therefore purine synthesis is inhibited. Well, who inhibits who inhibits dihydrofolate reductase? Right? There's many drugs that inhibit it, which we talked about in the pyrimidine synthesis video, but what's one of those drugs? Methotrexate. So not only does methotrexate affect pyrimidine synthesis, now we also found out that it affects purine synthesis also. Okay, so we have 3 drugs so far, 6-mercaptopurine, azathioprine, methotrexate, right? Let's talk about 2 more high-yield drugs, okay? So let's scroll all the way in the bottom let's go down to that slide again, and let's go to our next enzyme that's about to get inhibited, okay? So our next enzyme we need to focus on is, let's choose a different color, IMP dehydrogenase, all right? IMP dehydrogenase, what did that do? That took IMP and that converted it to what? GMP, okay? So if we inhibit IMP dehydrogenase, we can't make GMP from IMP. So what drugs would do that, right? First drug we should note is ribavirin. This drug, ribavirin, right? For example, if we're talking about real life significance of this drug, we can use ribavirin to treat a certain virus that's called RSV, right? Respiratory syncytial virus. And also, so another drug we can use to inhibit IMP dehydrogenase is mycophenolate. Okay, so we have 2 drugs that inhibits IMP dehydrogenase that we should know, ribavirin and mycophenolate. All right, so in total, we've talked about ribavirin, mycophenolate, azathioprine, 6-mercaptopurine, and methotrexate. All right, so that was basically all the drugs, but I do want to talk about one more thing before we end this video. So again, this will be a quick, good review. 6-mercaptopurine, what does that convert to? Right, 6-thioinosinic monophosphate, right? Who helps convert 6-mercaptopurine to 6-thioinosinic monophosphate? Hypoxanthine, guanine, phosphoribosyl transferase, right? All right, well, what does 6-TIMP do? Do we remember that? Remember it goes and it inhibits what enzyme? PRPP aminotransferase, right? Or also called glutamine phosphoribosyl aminotransferase. So in this case, I'll just write PRPP aminotransferase since it's shorter, right? All right, so 6-TIMP inhibits PRPP mitotransferase. Okay, and then remember, what's the prodrug of 6-mercaptopurine? Azathioprine. Okay, azathioprine. So I wrote all this out because there's one more thing that I want to talk about is you can give azathioprine or 6-mercaptopurine for things like, for example, leukemia, where you have to suppress the immune system. Okay, so again, you can use 6-mercaptopurine or azathioprine, right, for immunosuppression. But there's one thing we have to know about this, is that we have this other enzyme that's involved in the purine salvage pathway, which we'll talk about in a future video. The enzyme is called xanthine oxidase. Okay, xanthine oxidase is important for making uric acid. Okay, like you'll see, hypoxanthine gets converted to xanthine, and then xanthine gets converted to uric acid. All right, which we'll talk about in a future video. However, xanthine oxidase also inactivates a molecule like 6-mercaptopurine. Okay, it's going to turn it into inactive metabolites. So again, xanthine oxidase will take 6-mercaptopurine and make it inactive. Okay, so why is that bad? Well, if we're using 6-mercaptopurine for the purposes of immunosuppression, and we have something else that's inactivating it, we can't use it for immunosuppression anymore, right? Or we can, but it's going to get degraded pretty quickly, so it's not going to be as effective. So what if we gave something that inhibited xanthine oxidase, right? A xanthine oxidase inhibitor, okay? So what's an example of that? Which we'll again talk about when we talk about things like gout and purine salvage pathway. It's called allopurinol, okay? So if we gave allopurinol, that's going to inhibit xanthine oxidase. Therefore, xanthine oxidase will not be able to inhibit or break down or inactivate 6-mercaptopurine. Therefore, immunosuppression will be good to go, right? We'll be able to use 6-mercaptopurine for immunosuppression if we give that with xanthine oxidase. Okay, so that's something to know about xanthine oxidase and its relationship to 6-mercaptopurine and immunosuppression. All right, and that's basically all I wanted to talk about in this video. And then in my next future videos, we'll start talking about things like purine salvage pathways and diseases associated with that, and also drugs associated with that. All right, so I hope you guys enjoyed this video, and see you in my future videos. Thanks for watching.